Okay, so a lot of people have made videos explaining how ChatGPT works. Diagrams, arrows, boxes label attention. But most of them don't actually let you build something and watch it run yourself. So that's what we are doing today. We'll walk through the core idea behind how ChatGPT generates text, one word at a time, and then build a small working version of it, live in about 20 lines of Python. You don't need a neural network to understand the core mechanism. That's kind of the point. So this is called autoregressive generation, which basically just means each new word depends on the word before it. The model doesn't know the whole sentence ahead of time. At each step, it looks at what's been generated so far and figures out what exactly likely to come next. It picks one, adds it to the sequence, and then does the same thing again with a bit more context. This just repeats one piece at a time until it stops. Quick heads up, real models actually work on numbers, not words, and they look at a way more context than what we'll today. We'll build a simplified version, and I'll be upfront about exactly what's simplified once we are done. Alright, let's build it. One more thing before we build this. At each step, the model isn't just picking the single most likely word every time. It's sampling from a probability distribution. So if cat comes up 70% of time and dog comes up 30%, it won't always pick cat. Most of time it will, but sometimes it will go with dog instead. That's why you ask the same question twice and get slightly different answers. We are obviously not training a real neural network today. That needs way more data and way more compute. But we can build something that captures the real mechanism, using this tiny made up paragraph as our training text. We lowercase everything, split the periods off so they count as their own token, and split it all into a list of words. Here's the encoding step, and this part is actually real. This is what happens first in any language model, including ours. We take every unique word in our text and give it a number, word to ID, and the reverse mapping too so we can decode later. Then we turn our entire training test into a list of integers using that mapping. So from here on, our model never actually touches the word cat. It only sees whatever number it got assigned. This is our whole model, and it's basically just counting, but notice we are using the last two tokens as context now, not just one. For every pair of consecutive token, we look at whatever comes right after that pair and add 1 to the counter. So the model isn't just asking what follows cat, it's asking what follows the cat as a pair. That's a small step closer to a real context. Real models replace this counting with a neural network trained on billions of examples, and they look at a whole sequence so far. But the question they're answering is the same one. Given the context, what likely next? Here's the sampling step, and everything here is still in a number form. Context is just a tuple of two token IDs, not words. We grab every token ID that's ever followed this exact pair, along with how many times, and random dot choices with weights pick one. More likely to pick IDs with higher counts but not guaranteed. This one function is doing the same job as the sampling step inside a real language model, just at much smaller scale. Here's the actual generation loop. This is the part that matters most. We take our seed words, encode them into IDs first, same as the training data. Then, one token at a time, we look at the last two IDs we have, predict the next ID, and add it on. Only at the very end, we turn every IDs back into its word. That's the decode step. Encode the input, generate entirely in number space, decode back to the text. That's basically the real pipeline, just with a much simpler model doing the middle part. There it is, a fully generated sentence, and underneath, every step was just numbers being predicted and sampled. Let's run the exact same generation starting from the exact same two word 3 separate times. 3 different sentences from exact same starting point. That's not a bug, it's just the sampling step picking a different path through the probability distribution each time. Same idea as before, just with actual context behind each prediction now instead of just one word. That's basically why asking ChatGPT the same question twice can give you two different answers. Both are valid, both were likely, it just sampled differently along the way. One more thing before we wrap up. The encoding step we built is real. Word to number, generate in number space, decode back to words. That's actually how it works, just with a much smaller vocabulary. What's still simplified is the context and the model itself. We looked at the last two tokens. Real model look at the whole conversation so far, using something called attention, to figure out what actually matters. And our model is just counting. Real model replaces that with a neural network with a billions of learned parameters trained on huge amount of text. But the shape of the pipeline, encode, predict using context, sample, decode, feed it back in, repeat, that's part actually accurate. Just running at much smaller scale here. So that's basically the core pipeline behind every word ChatGPT, Claude, or any other language model generates. Encode text into numbers, predict a distribution based on context, sample one, decode it back, feed it as a new context, repeat. Full codes in the description. If you want the next one to cover how real tokenizers split words into pieces or how attention actually work, let me know in comments. See you in the next one. Peace.